Hey guys, in this video we are taking a look at a brand new theorem. So this guy is called the Factor Theorem, and although we're giving it a name, it's not really a new concept at all. But it is really helpful when it comes to factorising harder cubic equations or expressions. So, what is the Factor Theorem? Well, the Factor Theorem tells us that if f of a is equal to 0, then x minus a is a factor of f of x, where f of x is either a quadratic or a cubic or any higher powered polynomial. We call these things. Can't believe I got this far in this playlist without saying the word polynomial. Doesn't seem to be so much emphasis on them as there used to be back in my day. So, this really is not a new concept, as I said. Any time up to here where we've been solving quadratics or cubics, we are finding a value of x that makes the expression equal to 0, or it makes the equation, when we've already set that thing equal to 0, it makes that equation true. So what do I mean by this? Well, let's have a look at an example. So this bad boy here seems to be my go-to quadratic. We've seen it quite a few times in past videos. Let's say we'd forgotten how to factorise, and instead we thought, well, we could use the factor theorem here to solve this guy. So we'd be thinking, well, we know that when it's in factorised form, the two numbers in the brackets have to multiply together to give us positive 12. So let's say we thought, well, 2 goes into 12. So let's try f of 2. So we're substituting in x equals 2. Now this would give us 2 squared, which is 4, minus 7 times 2, minus 14, plus 12. So 4 minus 14 is minus 10, plus 12 gives us 2. Now the important thing there is that that is not equal to 0, so this would imply x minus 2 is not a factor. What about then if we thought, well, what about 3? So 3 goes into 12, definitely. Now because, I should also say, because x minus 2 isn't a factor, that means that x minus 6 cannot be a factor. If it was, x minus 2 would have to be. So let's try f of 3. Let's change colour to show we're trying a different number. So f of 3. Well, f of 3 would give us 3 squared, which is 9, minus 7 times 3, which is minus 21, and then add 12. Now, does that equal 0? Well, 9 minus 21 is minus 12. Add 12 gives us 0. Yay. So, this implies then x minus 3 is a factor. Now, how does that help us then? Well, we know then f of x is x squared minus 7x plus 12. Now we know So we've got this now factorised down to x minus 3. Now we know the other bracket has to have a single x in it. And we know the number in there has to multiply minus 3 to give us positive 12. So it has to be minus 4. Now that was a completely unnecessary example because we can factorise that quite happily, but I like to start with things we're familiar with, things that we're quite happy with, and now we're going to build up and look at some trickier examples. Okay, first up we want to use the factor theorem to show that x minus 5 is a factor of x squared minus x minus 20. So, if we sub in, well, if x minus 5 is a factor, then f of positive 5 will equal 0. So, if we put in x equals 5, let's call it f of 5, we will get 5 squared, 25, minus 5, and then minus 20. Now 25 minus 5 is 20, 20 minus 20 is indeed 0. Therefore, x minus 5 is a factor, as we wanted to show. Next, we want to again use the factor theorem to show that x plus 2 is a factor of the cubic, x cubed plus 6x squared plus 11x plus 6. So, if x plus 2 is a factor, then f of minus 2 will equal 0. Okay, so now be very, very careful with cubics and negative signs. So we can get minus 2 cubed plus 6 lots of minus 2 squared plus 11 lots of minus 2 and then plus 6, like that. So minus 2 cubed is minus 8. Now, minus 2 squared is positive 4. 6 times 4 is 24. Then we've got 11 lots of minus 2, which is minus 22. And then we've got plus 6 at the end. Okay, so what have we got here then? Well, so what I sort of like to do with things like this, I like to group together the same sign things. So we've got a positive 24 and a positive 6. So that's 30. And then we've got a minus 8 and a minus 22. Minus 8 minus 22 is minus 30, which is indeed equal to 0. Therefore, x plus 2 is a factor. Good times. Slightly trickier one up now. So we want to use the factor theorem to show that 2x plus 1 is a factor of 2x squared plus 11x plus 5. So what makes this a slight bit trickier is this potential factor, 2x plus 1. Now, we need to work out then, if that is a factor, what would x be? So, remember when we're solving quadratics or cubics by factorising, we get them in factorised form, and then we set whatever is inside each bracket equal to 0. So, if 2x plus 1 is a factor, then x would have to be, well, you set whatever is inside each bracket equal to 0, so 2x plus 1 equals 0, minus the 1, 2x equals minus 1, divide by 2, x is minus 1 over 2. So, we need to check then if f of minus 1/2 is equal to 0. So, that's going to give us 2 lots of minus 1/2 squared, add 11 lots of minus 1/2 plus 5 at the end. Now, minus 1/2 squared is positive 1/4. So we've got 2 times 1/4. 11 times minus 1/2 is minus 11 halves plus 5 at the end. 2 times 1/4 is 1/2 minus 11 halves plus 5. Now 1/2 minus 11 halves is minus 10 halves. So we got minus 10 halves plus 5. Minus 10 halves is minus 5. Minus 5 plus 5 is 0. Therefore, 2x plus 1 is a factor. Good times. Okay, this one's going to be fun, so we want to show that 3x minus 2 is a factor of 3x cubed minus 5x squared minus 16x plus 12. So, first of all, we need to work out what 3x minus 2 being a potential factor would make x. So, if we set 3x minus 2 equal to 0, 3x is 2, so x would be 2/3. So, if 3x minus 2 is a factor, then f of 2/3 will equal 0. So, we need to show whether or not it does. Good times. Okay. So, we're going to have 3 lots of 2/3 cubed minus 5 lots of 2/3 squared minus 16 lots of 2/3 and then plus 12 at the end. Cracking. Okay, so just go nice and steady. So 2/3 cubed is 2 cubed over 3 cubed. So here we've got 3 times 8 over 27. And then we've got minus 5 lots of, well, 2/3 squared is 4 over 9. Good times. Then we've got 16 times 2/3, or minus 8. So minus 16 times 2/3 is going to be minus 32/3. Like that. And then we got plus 12 at the end. Okay, well, 3 times 8 over 27 is gonna be, so if you like, you can think of 3 as being 3 over 1, like that. Now, when we do that multiplication, we're going to get 3 times 8 over 1 times 27. There's going to be a common factor on top and bottom of 3. So 3 times 8 27ths is actually 8 ninths, like that. And then 5 times 4 ninths, or minus 5 times 4 ninths, it's going to give us minus 20 ninths. And then we've got minus 32 thirds. Given though that these two terms before it are in terms of ninths, we want this term to be in terms of ninths too. So if we multiply the top and bottom by 3, we are going to get 96, or minus 96 ninths, like that, plus 12. So we've got 8 ninths, minus 20 ninths, minus 96 ninths. Good times. Well, 8 ninths minus 20 ninths is minus 12 ninths. Let's just do it nice and slowly. Then we got minus 96 ninths. And then plus 12. I never put my phone on silent. Now minus 12 ninths minus 96 ninths gives us minus 108 ninths. Plus 12. Now minus 108 divided by 9, thankfully, is minus 12. So we got minus 12 plus 12, and that does indeed equal 0. Now I've forgotten what the potential factor was. 3x minus 2. So we can now confidently say, therefore, 3x minus 2 is a factor. Awesome. Okay, to finish up then we got a nice big problem solving type question. Now we're probably going to see more of these when we get around to fully factorising and solving harder cubics, but let's do one now. So, simultaneous equations are also going to be involved here. So, x cubed plus cx squared plus dx minus 2 has factors x minus 1 and x minus 2. We want to find the values of c and d. So, what we're going to do here, we're going to use the fact that we know 2 factors, and we're going to substitute in the x values. We're going to end up with 2 equations in terms of c and d. So then we're playing simultaneous equations, we can then solve them for c and d. So, first up then, what do we know? Well, we know x minus 1 is a factor. So, if x minus 1 is a factor, then f of 1 is equal to 0. So, let's work out f of 1 would be. So, f of 1, well, it's going to be 1 cubed, which is 1. Add c times 1 squared, so that's just 1c. Add d times 1, so that's just 1d. Minus 2. Now we know that that is equal to 0. Because, again, x minus 1 is a factor, So that means f of 1 has to equal 0 by the factor theorem. Okay, so if we sort this out, 1 minus 2 is minus 1. So, let's write it in green. So 1 minus 2 is minus 1. So if we add 1 to both sides, we know C plus D is equal to 1. So there's our first equation in terms of C and D. Now, we also know that x minus 2 is a factor. So x minus 2 being a factor, so x minus 2 is a factor, and that implies f of 2 is equal to 0. So now we're substituting in x equals 2. So we're going to get f of 2 is going to be 2 cubed. 2 cubed is 8. Plus c times 2 squared. 2 squared is 4, so plus 4c. Plus d times 2, so plus 2d. And then at the end, minus 2. Now we know that that is equal to 0. Okay, so, well, we can sharpen this up a bit. We've got 8 minus 2 on the left-hand side. 8 minus 2 is 6. So, we can say we've got 4c plus 2d plus 6 equals 0. We can take away the 6, so 4c, add 2d is minus 6, and then we can simplify that a bit. We have a common factor of 2 running through, so we can divide that away. So we're going to end up with our second equation in terms of c and d in its simplest form. 2c add d equals minus 3. So we've now got our two equations. It's now simultaneous equation time. So we've got c plus d is equal to 1, which is equation 1, and 2c plus d equals minus 3. Like that. So that's equation 2. Now we're in a happy position here because we have two equations, both with the same amount of d in them. So we can eliminate the d's by doing which way around are we going to do it. Let's do equation 2, take away 1. So that's going to give us 2c minus 1c, so we're going to end up with 1c. D minus d is 0, minus 3 minus 1 is minus 4. So c is minus 4. Good times. So let's change colour because we're doing something different now. Now that we know what c is, we can find the value of d. So if we substitute c equals minus 4 into equation 1, minus 4 plus d is equal to 1, add 4, d is equal to 5. So there are our answers. C is minus 4. D is equal to 5. Good times. Okay guys, that's it for the factor theorem for now. If you want any more questions on these, that in particular got quite tricky there. So if you want more example questions like that, let me know down below in the comments. Next up, we're looking at another theorem called the remainder theorem, and then we'll be looking at factorising fully and solving harder cubic equations. Take care guys.